Hey guys, it's Sam here, and today I'm going to be taking a look at these. So these are high-end, custom interpolated animations in Minecraft using armor stands. So the way this works is that each armor stand is running an MC function file every tick, which looks at a scoreboard objective that determines the frame and sets its pose accordingly. Now, these would have been really hard to code manually, but I didn't code them manually. I mean, who's going to manually code every frame of an animation? I guess that's what animators used to do before computers were invented. But whatever, computers have been invented. So we got to do this a better way than just coding these manually. And the way I did these was I wrote a Blender add-on and a custom Java program, which would write these functions for me. And today, I'm going to show you how you can do this yourself. I mean, use the program I wrote. Writing a program is really hard. In this tutorial, I'm going to go over installing the program and add-on, exporting your animation from Blender, opening the animation in my program and compiling it to a function file, and activating that function file in your data pack. I am not going to cover the basics of data packs or the basics of animation in Blender. There are plenty of tutorials of both of those on the internet. To get this working, you're going to need to download things from two GitHub repos, the compiler and the exporter for Blender. Both of these will be in the video description. Let's start with the compiler. The compiler is built in Java. If you don't have Java, scroll down to this link and click on the Oracle website button. That will take you to the Oracle website where you can download Java. You can ensure you have Java installed by going to the command prompt and typing java-version. I've used Java 1.8 to build this program. Once you're sure you have Java installed, go over to the Releases tab and download the newest release. This program is in early alpha and will have a lot of bugs. Make sure to tell me if you find some. Let's go ahead and click the download button and hit keep. Next, let's download and install the Blender add-on. Go ahead to the Releases tab and click on minecraftanimation.zip. We'll go ahead and download that and then open Blender. If you don't have Blender, you can download it from the link in the video description. I will be using Blender 2.79b for this tutorial, but any subsequent version should work. Let's start by going up to File, and then click User Preferences. Come over to the Add-ons tab, which I'm already in, and click Install Add-on from File. Now we navigate to the Downloads folder where we installed our zip file. Go ahead and click that, and Install from File, and it should be installed. Now that we've got it installed, come up to the search bar and type Minecraft. You should see this appear. Click the check mark to activate it. Once it's activated, click Save User Settings so that you don't have to activate it each time, and click the X. Now we have successfully installed everything and are ready to start work on our animation. This is the part where I want to make it abundantly clear that this is not a beginning Blender tutorial. If you want to learn Blender, go somewhere else on the internet. Because of this, I'm going to be doing relatively high-level actions here without stopping to explain what I'm doing. But feel free to continue watching if you're curious to know how this works, or if you already know Blender, because a lot of people do already know Blender. With that said, let's go ahead and delete everything in the scene here, and come over to the Minecraft tab, which I've already got open, and click Spawn Armor Stand. So this spawns the mesh and the armature that this system requires to function properly. This armature is set up specially to mimic the armatures that armor stands use in Minecraft. So it's what we need to animate. So let's go over to pose mode, and we can animate this to our heart's content. So I have gone ahead and animated this little guy waving. It's not a very complex animation, but it's enough to get us started. If you don't want to spend the time animating something, this will also be available for download in the description. So one important thing to note here is that this sequence is a looping sequence, and I have set the end frame to be 20. Your animation will be as long as your timeline is. So if you start at frame 1 and end at frame 20, it means your animation will be 19 frames long. That is perfectly fine in this circumstance, but if you're doing a shorter animation, just remember to actually cut down your timeline, or you will have a bunch of wasted space at the end. When we're ready to export, let's go ahead and make sure our armature is selected, and go to File, Export, Minecraft Animation. This will pull up this screen, and where you have these options. So looping does what it says it does. If this is unchecked, the animation will play through once, and then the armor stand will just hold there. If it is checked, though, the animation will keep repeating indefinitely until you stop it manually with a command. Next is reset when done, and this is designed for animations that have root motion, like rotation or position changes, like you saw at the beginning of this video. If checked, when the armor stand is finished, it will teleport back to its initial position. If unchecked, when the animation is finished, it'll just stay there, and if the animation is played again, it'll then be played to that new location. Finally is ID. The ID is the most important part because it is how Minecraft knows what animation to be playing. Now the ID must be unique for each animation, so you can't have two animation 1s, but you can have an animation 1 and an animation 2. That's how Minecraft knows which animation to be playing. So I'm going to go ahead and set this to animation 1 because why not? I don't have any other animations. And we'll go ahead and save it as demoanim.mcanim and export. So it's a relatively fast export, and if we go in here, we should see demoanim.mcanim. So this is a custom file format based on the JSON format, which basically stores all its frames in plain text, and the compiler knows how to read it. Next comes the part with the compiler. The compiler is a little bit less straightforward than Blender because it's a command line tool, but you still get the hang of it pretty quickly. So we'll start by going to the command prompt on Windows, or as many people call it, CMD, and if you're on Mac, go ahead and open Terminal. The next thing to do is to navigate to your Downloads folder, or wherever you put the jar file. This is where having some knowledge of the command prompt will come useful because you can, I guess, copy-paste my commands as much as you can on Windows, but there's going to be variability between everyone. So for me, I'm going to go ahead and CD into my Downloads folder. And if I go ahead and type dir, we should see mcanim.jar. That's what we need. So in order to get this to run in the command prompt, we're going to type java-jar and then the jar name. So mcanim.jar and enter. And now we have launched into the compiler program. So the compiler program has a lot of different functions it can do, and I'm going to show you only a couple of those, but you can always download it and type help and experiment with yourself. So the first thing we have to do is to open our file. So I'm going to go ahead and type open, and I'm going to go ahead and, on Windows you can do this, I'm not sure if you can do it on Mac, but drag in the mcanim file and hit enter. So it should say interpreting mcanim version and then whatever version is active at the time of you watching this. And it should say loaded animation demoanim, which was the file name, and the animation ID, which we set in Blender, which was 1. Now there's a couple things we can do here, like we can say get ID, and it then says get the ID, and it also says the parameters that we can also get. So we can get the length, and now it says it's 19 frames, which is what it's supposed to be. So one of the big things we can do is add a command that will be run every time the frame is played. So let's go ahead and locate a frame in Blender again that we want to run a command on. So here's our Blender file. I'm going to go ahead and run through this, and I guess why not just do it on frame 1. So one of the things I highly recommend doing is testing your commands in Minecraft before you go ahead and add them to the animation. Because if there's any commands in the animation that aren't properly formatted, the animation won't run at all. So I found a good command here. It's a simple play sound command, but I think it'll work. So let's go ahead and Control-C to copy that. And now we Alt-Tab over into our program, and we said we wanted to do it on frame run. So we're going to say command set 1, and then we paste in our command. One thing I want to point out is that you can only have one command per frame. If you want to run multiple commands per frame, you should put them in a function. This is to ensure that the commands are actually run in the right order, as the way it's currently set up, if you had multiple per frame, they might be run in the incorrect order. Now that we've added our command, we can go ahead and type export to a function file. And there we go. One thing you may notice is that it's given you a command here. This has to be run every tick or else the animation will not play. I've summoned in an armor stand without a base plate and with arms to demonstrate putting our animation onto. So how am I going to put the animation on this armor stand? Well, by screwing with the data pack. Now, I'm not going to go into how to make data packs in general, because I'm assuming that if you are making an adventure map that requires this level of advanced animation, you already know how to do that. So let's just jump into it. So here I am in a basically empty data pack. All I've got here is the correct file structure setup and the other data pack stuff, and an init function and a tick function. And these are both set to run on init and run on tick respectively. So let's start with the init. Here we're going to go ahead and set up some commands to set up some scoreboard objectives. We're going to need 3 objectives for this. So let's start with scoreboard objectives, add, and we're going to call the first one mcanim.anim, and this is going to be a dummy. What this will represent is the animation ID of the animation that the armor stand should currently be playing. The next one should be another objective, so let's go ahead and add an objectives. We're going to call this one mcanim.frame, and this is also going to be a dummy. These are all dummies. And what this represents is the current frame that the armor stand is currently in. And the final one, let's do scoreboard objectives, add mcanim dot paused dummy. And I never really went into much depth about what this did before, but essentially, if this is set to anything other than 0, the animation will not play. But if it's set to 0, it will play, and this is designed as like a sort of pause feature. And all of these have to be named exactly this: mcanim.anim, mcanim.frame, mcanim.paused, with all of these in here. So now we've got the init done, we can go ahead and save that and close, and now we've gone on to the tick. So the tick's relatively simple. So come over to the compiler here, and we're going to go ahead. When you compiled, it gave you this command. You're going to take this, and you're going to copy it, and you're going to paste it in here. And this can be any tick function. And when I was setting this up, I actually had a dedicated function for anim ticks, but since we're only doing one, I'll put it in the tick function. And let's go ahead and save that. Now we're done in tick. I'm going to go ahead and close that out. And finally, let's go ahead and locate where we exported that MC function from the compiler. Here we go. We've got anim1.mc function. So what we're going to go ahead and do is in here, we're going to make a new folder. And that's going to be called animations. Just plain old animations. And it has to be called plain old animations if you want to use the command that's applied to you from the compiler. Now we can go ahead and take our anim1.mc function file and just put that in here. And theoretically, we are now done. If we come over into Minecraft and type /reload, now we go ahead and set the armor stand to have the right scoreboard objective. /scoreboard players set, and I called this armor stand test2, sorry. So I'm going to say name equals test2, and I'm going to say mcanim.anim is 1. Shit, okay. Okay. You know, I'm going to go ahead and leave this in because it's funny, but I just got scared the crap out of by that anvil sound. But anyway, we have now got the anim working, and as you could probably tell by this really loud and obnoxious noise, the anvil is working as well. I'm going to turn my sound down. But yeah, so that's how you make animations. Now this can have root motion, this can have, in the future we'll have any kind of rotation, but right now it just has rotation like x-axis. So that's the animation system. There are a couple limitations to this system, which are, since it is run every tick, the animation speed is limited by your tick speed. So if you do have a lot of complicated functions that are slowing down your ticks to less than 20 hertz, your animations will run slower. And that is just an inherent flaw in the way Minecraft is designed, and there's nothing I can do about that. Also, you can't rotate the torso. So if anyone knows how armor stands work, for some reason the torso's origin when you rotate it is at the neck, which means if you try to rotate the torso, it is going to detach from the legs, and the rig is set up to mimic that. So if you do want to do it for some reason, you can do that, but you currently can't realistically rotate the torso. I might do a system in the future where it'll intelligently use 2 armor stands to kind of simulate it, but as of now, you can't really rotate the torso. But I guess that's all there really is to the system. Comment if you liked it. Make sure to tell me if you're using it in something. I mean, it's all open source. I don't really care if you use it. Do use it. I'm making it for people to use, but if you use it, tell me. I want to know. I want to know what it's used in. But yeah, comment, rate, subscribe, and I will see you next time.